So to my eye, it feels like the mean of all these numbers is a little higher, which to me indicates like value, right? More epochs or, you know, a different sized model. But there's something here, right? What do you guys think? That's just my observation, right? These are the conversations you have in the team room, right? Like, hey, this is how I see it. How do you guys see it? But to me, the mean seems to have gone up. Leo says, and also the loss, I don't think it's higher than before. Yeah, Leo, I mean, it doesn't look too terrible, right? I mean, the end result, the 0.32 at the end was not great, but overall, it's not terrible. So I agree, Leo. Rahul says, yes, I agree. The mean is higher, the variance is low. Yeah, Rahul, and that's a good thing, right? Like, to me, that's like, you know, like one of those signs of life, right? Like, you want to have those things. So yes, maybe the accuracy isn't what we had before, but there's potential here, right? Monium says it seems with this instance, based on the validation accuracy, it went up. No, validation accuracy went down, my friend. We could employ early stopping and avoid overfitting here. But it actually went down. If anything, we'd have to run more epochs to determine that, right? But no, our validation accuracy went down. We got 0.915 was our baseline. All right, let's go to PyTorch. Actually, let me shut. I gotta shut this. Okay, so let's try PyTorch. I already made the code changes. Yeah. Oh, did I make a mistake there? Did I make a mistake there, guys? Does anybody spot that mistake? Just verify that. Yeah, 20 to 128, 128 to 64, 64, 32, 16. Yeah, Leo, so the error is saying, let me bring that back up. For mat 1 and mat 2, shapes cannot be multiplied 32 by 128 and 64 by 132. And it's on the model side. Ah, thank you, Monium. Yes, you're right. Thank you, thank you, thank you. Yep. Oh, yes, yes, yes. Sorry about that, guys. 5, you're right. Yeah, I try to make those changes too quickly. Thank you so much. Guess this needs to be. All right, so Karis wins and how quickly we can make those changes. Yeah. Yeah, thank you, Monium. A great catch. I was just too quick in making them. 1, 2, 3, 4, 5. 5 is our activation layer, output layer. Yeah. Change the naming FC in the forward. Yeah, I think I got them all. Thank you so much for that. Yeah. Okay. All right. What do you guys think? Monium says, and that is why Karis rocks. Nice, Monium. Monium understood the assignment. Thank you, my friend. What do you guys think? Leo says not much of a difference. Okay. Compared to Karis. Okay. Anybody else? I think Leo's making good observations, right? Rahul says huge variability in the loss, accuracy is slightly better. Yeah, Rahul. Both of those items caught my eye. Again, if we just get like a sense for the mean here, seems super high, right? Some of these values that we're seeing in this loss were outliers in our previous tests, right? In some of those other tests, we were getting 0.0 something, right? We saw an 09 and 06. We're not seeing any of that. We're seeing a 5.7, a 4.3, a 3.7, a 7.3. These are terrible losses, right? So it does feel like it's variable and the mean is higher. But having said that, another thing that's jumping out at me is, guess what? On the PyTorch side, if we just think about PyTorch, this is our highest accuracy number yet. Right? This is the first time we've seen a 91 from PyTorch. So, is that good? Is that bad? I don't know. Depends on the use case. Depends on what you think about PyTorch as far as like where you can take the code. Leo says, yeah, Leo. I mean, I think it's clear, right? Like if you look at these numbers, like the mean of the loss is probably the highest we've seen. Like 0.73 for a loss? That's terrible. Even 0.33 is, not so hot. Right? The confusion matrix looks okay, right? Class 1 and class 3 are excellent. Yassine says, if I remember correctly, the code that generated the data used 15 informative features, just a dumb thought, but wouldn't it make sense to use a layer with 15 neurons before the output layer? My rationale is if we already know how many variables are significant, let's consider every neuron as a variable and let the model learn them. So Yassine, it's not the output layer, it's the input layer that matters at that point. Right? See, I'm not on board with where you said about the output layer, because your features and your outputs are, there's no relationship there. Your inputs are what they are, and your outputs are what they are. They're completely independent of each other, right? I mean, that's why you have the layers in between, because the layers and those calculations is what helps you make those relationships, right? Those relationships that you can't see. But there is no correlation between your inputs and the number of outputs. In many cases, like, well, it's much more common for the outputs, but in many cases, they'll be dictated to you, right? Like, the number of categories your business needs is what the business needs. You don't decide that, and the features don't decide that. So no, Yassine, I'm not on board with that, because they're completely independent of each other. On the input side, it matters, right? 20 features needs 20 nodes to start off. But otherwise, no, doesn't matter. They're completely independent. But I'm still confused in real world scenarios. How would I select a model? What balance of losses and accuracy is what I'm looking for? Yeah, Rahul, depends. It all depends. It depends on the use case. And again, some of those, they might be dictated to you, right? So for example, going back to this chart here with the classes, let's talk about this chart. Can I make this a little bigger? I can, cool. Let's talk about this chart. So I know it says the class 0, 1, 2, 3, 4, but these in most scenarios, these would be like product classes or some sort of end result to a process, to a sales process, to a production process, whatever, right? So the business might dictate to you what they need out of this, right? So let's take class 3, right? Class 3 is properly classifying 393 of the 400 items that are in that data set, okay? And you know that the accuracy here is 91, the loss is a little shaky, right? We've already agreed on that, right?